Tesla's 2026 new battery ends lithium forever. And if you're watching this right now, you're seeing the beginning of a shift most people won't understand until it's already happened. You're about to discover what Tesla's been quietly engineering behind the scenes, why lithium's reign is on a countdown, and the exact technology that's about to make everything you thought you knew about EVs completely obsolete. This isn't just another battery announcement. This is the moment Tesla stopped playing defense and went on the attack. For years, the entire industry has been trapped in the same game: squeeze more range out of lithium, manage the fires, deal with the supply shocks, and hope the price comes down. But while everyone else was optimizing the old system, Tesla was building something entirely different. Not an improvement, a replacement. And it doesn't just solve lithium's problems, it makes lithium irrelevant. The question isn't whether this changes everything, it's whether you're ready to understand what comes next before the rest of the world catches up. Let's find out. The 4-chemistry weapon. Here's what nobody's talking about. Tesla didn't just build a better battery, they built 4 of them, and each one is designed to kill a different part of lithium's empire. Tesla's 2026 innovation isn't a single breakthrough, it's a weapons system. 4 distinct battery chemistries, each designed to destroy a different weakness in the old lithium empire. They call it the NC series: NC05, NC20, NC30, NC50, and each one targets a specific battlefield where lithium has failed. Here's what makes this strategy devastating. While other automakers are still trying to perfect one lithium battery for every car, Tesla has built 4 specialized tools. It's not just smarter, it's the difference between fighting with a Swiss Army knife and fighting with a complete arsenal. NC05, the mass extinction event. The NC05 is designed for one purpose: make EVs so cheap that gas cars become financially irrational. This is the battery going into the $25,000 Tesla and the Cybercab robotaxi fleet. It's not the most powerful, it's the most scalable. Tesla has stripped away every expensive component, simplified the manufacturing to pure dry electrode production, and optimized for cost per mile.
Think about what that means. A robotaxi that costs less to build than a Camry, runs 24/7 without refueling, and never needs a battery replacement in its lifetime. The NC05 doesn't compete with Uber, it erases it. NC20, the workhorse that never quits. The NC20 is built for punishment: Cybertruck, Model Y, heavy SUVs, vehicles that tow, haul, and operate in conditions that would destroy traditional lithium packs. This variant uses the Gen 2 shell, 30% lighter than the original 4680, but engineered for maximum durability under load. Here's the hidden advantage. The NC20 is a structural battery. It's not just sitting in the vehicle, it is the vehicle. The battery pack forms part of the chassis, eliminating weight and increasing crash safety. That means more range, better handling, and a design that turns the battery from a liability into an asset. NC30 and NC50, the silicon revolution. This is where Tesla leaves lithium in the past. The NC30 and NC50 use silicon carbide anodes, a material with 10 times the energy capacity of graphite. Lithium has always relied on graphite because silicon expands and contracts during charging, cracking the battery and killing its lifespan. Tesla solved it. By mixing silicon carbide with graphite, polymers, and carbon nanotubes, they created an anode that flexes without breaking. The NC30 powers the long-range Model S and X. The NC50 is reserved for the Plaid and the next-generation Roadster. Here's what that unlocks. The Roadster is rumored to achieve over 600 miles of range, with a battery pack light enough to hit 0 to 60 in under 2 seconds. That's not an EV, that's a physics demonstration. The dry electrode breakthrough. But here's where it gets insane. Tesla just solved a 7-year manufacturing problem that every expert said was impossible, and the solution they found doesn't just make batteries better, it makes every factory on Earth that doesn't have this technology completely obsolete. How Tesla turned a 7-year manufacturing nightmare into a production weapon. Tesla bought Maxwell Technologies in 2019 for one reason: dry battery electrode technology. The promise was simple: eliminate the toxic solvents, massive drying ovens, and complex manufacturing required for traditional lithium batteries. But for 7 years, it didn't work. Cathode materials were too brittle. The film wouldn't form correctly. Production speeds were unusable. In 2026, they cracked it. And the solution is now the most important manufacturing advantage in the entire EV industry. The problem with wet manufacturing. Traditional battery production is a chemical nightmare. Electrode materials are mixed into a toxic slurry using solvents like NMP. That slurry is coated onto metal foil, then dried in massive ovens that consume enormous amounts of energy. Then, the solvents have to be recovered, recycled, and managed as hazardous waste. It's slow, it's expensive, it's environmentally destructive, and every major automaker on Earth is locked into this process. The composite binder solution. Tesla's breakthrough is patent US 2025/036456. Instead of using pure PTFE as a binder, which required up to 10 calendaring passes and still cracked, they developed a composite binder system. PTFE mixed with chemically stable polymers like PVDF or polyethylene oxide. This composite binder does something revolutionary. When processed through high shear jet milling, it fibrillizes into a spiderweb microstructure. That microstructure holds the electrode materials together without solvents, without drying, and without cracking. The result? Manufacturing speed triples. What used to take 10 passes now takes 3, and the entire toxic solvent recovery process is eliminated. Why this is a cost moat? Dry electrode production isn't just faster, it's a permanent cost advantage that competitors can't replicate without abandoning billions in existing factory infrastructure. Tesla's gigafactories are now producing 4680 cells at a cost per kilowatt hour that traditional manufacturers physically cannot match. This isn't an incremental improvement, it's a generational leap that makes every wet process battery factory on Earth obsolete the moment it scales. Sodium-ion, the lithium killer. Now let's talk about the move that changes everything. Tesla isn't just improving lithium batteries, they're replacing lithium entirely. And they're doing it with something so abundant, so cheap, and so safe that the entire supply chain is about to flip overnight. How Tesla is weaponizing abundance against scarcity. The ending lithium forever isn't hyperbole, it's strategy. And sodium-ion batteries are the execution. Lithium is rare, geographically concentrated, and subject to massive price swings. Sodium is the 6th most abundant element on Earth. It's in ocean water, it's in salt flats, it's everywhere. And in 2026, Tesla has advanced sodium-ion chemistry to the point where it can replace lithium in mass-market vehicles and stationary storage. The technical advantages. Sodium-ion batteries have 4 critical advantages over lithium. 1. Safety. Sodium-ion cells don't suffer from thermal runaway. They're chemically stable, non-toxic, and nearly impossible to ignite. 2. Temperature resilience. Sodium-ion retains 90% of its energy capacity at -40 degrees Celsius. Lithium batteries lose most of their power in extreme cold. This makes sodium-ion ideal for northern climates and commercial fleets. 3. Cost. Material costs for sodium-ion are 30 to 40% lower than lithium iron phosphate, or LFP.
That cost advantage flows directly to the vehicle price. 4. Discharge tolerance. Sodium-ion cells can be fully discharged to 0 volts without damage. That simplifies shipping, storage, and recycling. CATL's Nextra and the 50% market shift. In early 2026, CATL, the world's largest battery manufacturer, announced its second-generation sodium-ion battery, the Nextra. It achieves 175 watt-hours per kilogram, putting it in direct competition with first-generation LFP. CATL projects that sodium-ion will eventually capture 50% of the market currently dominated by LFP. Tesla's strategy is clear. Use sodium-ion for standard range vehicles, Powerwalls, and Megapacks. Reserve lithium for high-performance and long-range models. By diversifying chemistries, Tesla eliminates the supply chain vulnerability that has plagued every other automaker. This isn't hedging. This is systematically removing lithium as a bottleneck, while competitors remain entirely dependent on it.
Solid state and the Roadster wildcard. But if you think sodium-ion is the endgame, you're not seeing the full picture. Because Tesla has one more card to play, and this one doesn't just end lithium, it rewrites the laws of physics for what a battery can even do. The silent partnership that could redefine what battery even means. While the 4680 and sodium-ion represent Tesla's industrial-scale assault on lithium, there's a third layer, solid-state batteries, and 2026 is the year they go from lab prototype to production prototype. QuantumScape and the mystery OEM. QuantumScape's QSE5 solid-state cell achieves 844 watt-hours per liter and charges from 10% to 80% in under 13 minutes. Industry speculation, supported by patent filings, suggests Tesla may be the unnamed OEM testing these cells. Tesla has filed patents for pressure-based systems that provide uniform compression on pouch cells, a mechanical requirement unique to QuantumScape's lithium metal design. If Tesla integrates solid-state into the next-generation Roadster, the performance becomes almost absurd. An 80 kilowatt-hour solid-state pack at 500 watt-hours per kilogram would enable over 1,000 kilometers of range while keeping the vehicle light enough for sub-2-second acceleration. The Chinese low-pressure breakthrough. Parallel research from Chinese institutions in early 2026 introduced a new inorganic solid electrolyte that operates under just 5 megapascals of external pressure compared to the 100+ megapascals required by traditional solid-state designs. This makes solid-state compatible with Tesla's existing roll-to-roll manufacturing processes. This is critical. Solid-state has always been a lab curiosity because it couldn't be mass-produced, but if the pressure requirement drops, the entire manufacturing barrier disappears. Why this matters beyond the Roadster? Solid-state isn't just about performance, it's about energy density so high that battery weight stops being a constraint. Imagine a semi with 1,000 miles of range that weighs the same as a diesel truck. Imagine a Cybertruck that can power a construction site for a week. Imagine a Model 3 with 500 miles of range that costs less than a Honda Civic. That's not the future, that's 2027. Now here's the move that nobody saw coming. While everyone else is fighting over lithium contracts, Tesla just built their own lithium refinery. Not to buy lithium, not to refine it better, but to control the entire supply chain and produce zero toxic waste while doing it. How Tesla built a lithium monopoly while everyone else was buying from China. Even as Tesla moves towards sodium and silicon, high-nickel lithium batteries remain essential for the Cybertruck, semi, and performance models. So in January 2026, Tesla did something no other automaker has done. They opened their own lithium refinery. The facility in Corpus Christi, Texas, produces battery-grade lithium hydroxide for 50 gigawatt-hours of capacity per year, enough for 1 million vehicles. But the real innovation isn't the scale, it's the process.
zero toxic waste. Traditional lithium refining produces toxic sludge that has to be stored in evaporation ponds. Tesla's process produces inert byproducts, sand and analcime, both of which can be repurposed for construction materials. No hazardous waste, no environmental liability, just clean lithium and reusable material. Supply chain domination. By vertically integrating lithium refining, Tesla achieves three strategic advantages: supply security, no reliance on Chinese refiners who control 70% of global lithium processing; cost control, immunity to lithium price volatility and import tariffs; ESG compliance, lower carbon emissions through localized production and optimized water management. This is the quiet part of Tesla's strategy. While everyone else is negotiating contracts with overseas suppliers, Tesla is producing its own lithium domestically, at lower cost with zero environmental footprint. It's not just vertical integration, it's a fortress.
The 90% charge limit revolution. And just when you think Tesla's done, they pull off something that sounds impossible. They just gave every Tesla owner a 12.5% range increase. Not with a new battery, not with a hardware upgrade, with a software update. Let me show you how they did it. How Tesla turned a safety restriction into a 12.5% range increase overnight. For years, Tesla owners have been told, don't charge your nickel-based battery above 80% for daily use. High voltage degrades the cathode. It shortens the lifespan. It's the price you pay for energy density. In late 2025, Tesla announced a new nickel chemistry that raises the daily charge limit to 90%. That single change increases usable range by 12.5% without adding a single cell to the battery pack. How they did it. 3 chemical innovations made this possible. Dicarbonate solvents. Dimethyl 2,5-dioxyhexane dioate, or DMOHC, maintains stability at high voltages and temperatures up to 85 degrees Celsius. LiFSI salts. Improved electrolyte salts minimize gas buildup and prevent the swelling that can lead to rupture or fire. Single crystal cathodes. Use of single crystal NCA technology increases the voltage platform while maintaining thermal stability comparable to LFP. What this means for owners. A long-range Model 3 with 358 miles of range at 80% now gets 403 miles at 90%. A Model S Plaid goes from 396 miles to 446 miles. And these aren't theoretical numbers. This is happening right now through an over-the-air software update. Think about what that represents. Tesla just gave every nickel chemistry vehicle on the road a free 12.5% range boost. No hardware change, no service appointment, just better chemistry and smarter battery management. That's not an upgrade, that's proof that Tesla is still finding performance in batteries everyone else thinks are maxed out.
The collapse of the old guard. So here's the question nobody's asking yet. If Tesla just weaponized 4 different battery chemistries, solved the manufacturing bottleneck, and locked down the supply chain, who's actually ready to compete with that? Let's find out who survives this transition and who doesn't. Who survives the multi-chemistry transition and who doesn't? The 2026 battery landscape isn't just about Tesla. It's about the entire industry fracturing into winners and losers. And the dividing line is simple. Can you produce multiple chemistries at scale, or are you locked in to lithium? BYD versus Tesla. 2 philosophies. BYD's Blade battery uses lithium iron phosphate, LFP, in a prismatic format. It achieves 160 watt-hours per kilogram and 355 watt-hours per liter. Respectable, but far behind Tesla's 4680 at 241 watt-hours per kilogram and 643 watt-hours per liter. BYD's advantage is volume efficiency and cost. Tesla's advantage is performance and flexibility. But here's the problem for BYD.
They're locked in to LFP. They don't have a sodium-ion option at scale. They don't have a silicon-carbon anode. They don't have a solid-state roadmap. They're optimizing one chemistry, while Tesla is deploying 4. The manganese-rich middle ground. Beyond Tesla and BYD, 2026 has seen the rise of manganese-rich chemistries, LMR and LMFP. These cobalt-free architectures offer 33% more energy density than LFP at comparable cost. Companies like GM and LG are betting on this as a bridge between LFP and high-nickel NMC. But even this is a defensive play. Manganese-rich batteries are still lithium-dependent. They still face the same supply chain risks. They still require wet process manufacturing. Tesla's NC05 variant may use LMFP for cost reasons, but it's a temporary stepping stone. The long-term strategy is clear: sodium for mass market, silicon carbon for performance, solid state for the future. The companies that won't make it. If you're an automaker in 2026 and your entire battery strategy depends on securing lithium supply contracts, you're already obsolete. The market is moving to multi-chemistry ecosystems, and the cost gap is widening every quarter. Tesla's dry electrode process, sodium-ion pivot, and vertical integration create a cost moat that traditional manufacturers cannot cross without abandoning their existing infrastructure. And the longer they wait, the wider the gap becomes. This isn't a race, it's a culling.
Now, if you've made it this far, you're clearly not here for surface-level EV news. You want to understand what's actually happening before everyone else figures it out. So here's what I need you to do. First, subscribe to this channel. We're tracking every move Tesla makes in this battery war, and the next 12 months are going to be absolute chaos. You don't want to miss what's coming. Second, drop the word obsolete in the comments right now. That's your signal that you understand what just happened. While the rest of the industry is still optimizing lithium, you now know they're building on a foundation that's already crumbling. Comment obsolete if you see it. Let's get back to it. The empire that lithium built is over. This isn't the slow evolution of battery technology. This is a strategic demolition of the entire lithium-dependent system. Tesla's 2026 battery strategy, the NC series, dry electrodes, sodium-ion, solid-state prototypes, and vertical lithium refining, represents a complete rethinking of what an EV company can be. The old model was simple: buy batteries from suppliers, assemble cars, hope the supply chain holds. Tesla has exited that model entirely. They design the chemistry, they manufacture the cells, they refine the raw materials, they control every layer of the stack. And the result is a product that competitors can see but cannot replicate. Not because the technology is secret, but because the entire business model is fundamentally different. Lithium isn't ending because it doesn't work. It's ending because Tesla built something better, cheaper, safer, and more scalable. And once the industry realizes that sodium-ion, silicon carbon, and dry electrodes are the new baseline, the race is already over. So here's the question you need to ask yourself. Are you ready for a world where the battery is no longer the bottleneck, where EVs are cheaper than gas cars, last longer than gas cars, and outperform gas cars in every category? Because that world isn't coming. It's already here. The shift has begun, and the only question left is whether you were early enough to see it. The end of lithium isn't a prediction, it's a fact, and Tesla just proved it.